Right, today, so what we're going to do today is we're going to work backwards. Last time we had the equation and we built the graph. This time we're going to be given the graph. We need to find the equation. And it's really a very easy process if you think about the pieces that we've been talking about, right? The turning point of a parabola is called its what? Vertex, and there's a special vertex form of an equation, yes? Right? The places where the parabola crosses the x-axis are called the x-intercepts, and there's a special and you know that those are the values when you solve for x. So those are the things that are with your x, right? Okay? And we also know that we can find the y-intercept. That's the place where the line crosses the y-axis, right? Which is a nice, easy spot to use if you can find it, because x at that point is always 0. And anytime you can use a value of 0 when you're doing some math, we like it because it makes things go away. So we're going to talk about finding the equation. And when you're doing that, when you're finding the equation of a parabola from the graph, there are two methods. And you need to be aware that in graphing, the method you use is always determined by the type of information that you're given. So, for example, if it's easy to find the vertex, then the equation I want to use is the vertex form, right? Because you just plop those numbers right in from the vertex. If you know that if it's easy to find the x-intercepts, then we're going to use another form. It looks like that factorized form where you have the two brackets. So we're going to talk about that one first. The first one, okay, is when you know the x-intercepts. Now, x-intercepts plural. What if there's only one x-intercept? Then that point is also the vertex. There you go. It's also the vertex. And if that's the case, you use the other one, right? Does that make sense? So x-intercepts. When you know the x-intercepts, this is what you're going to do. Okay? First step. Put the x values. Now, just the x values from those points is all we're interested in. Those two x-intercepts. We're looking for those x values. Put those x values into the form y equals a times x plus or minus p, and I'll explain this in a second. Just go ahead and write it down. X plus or minus q. Now, don't freak out about the p and the q. Those are just the numbers of the x-intercepts. So they just had to assign some value to be able to look at them. It doesn't matter what they are. It's just the x-intercepts. And so p and q are the x values of the x-intercepts. So they're just using some letters to hold the place. And it's going to be either positive or negative depending on where it's located on the x-axis. Yeah? All right? Now, remember, when you put those in place of the p and the q, though, you're putting a number in a bracket with an x. What's that going to do to it? Change the sign. So make sure that when you plug those in, you change the signs. So it's not going to, if my x value is positive 2, it's not going to be x plus 2, it's going to be x minus 2, right? Taking it away from an x changes the sign, putting it back changes the sign. Okay? Now, and you also see there's another variable in there, the a. Not worried about the y, that's just the y from the equation, right? But the other thing is the a. And a is simply a constant. Oops. Write anything about it. A is a constant. And we'll talk about how to find it. Okay. And if any, there's always a constant. There's always a number in front. But if you don't see it, you assume it to be a 1. And many, many, many times when you're graphing these, a is going to be 1. Okay? Now, if you look at your parabola, you can kind of tell if a is going to be 1 by the width of the parabola. If it's very, very skinny, that means you have an a that's a whole number, right? If it's really wide, that means you have an a that's a fraction or a decimal. If it looks about normal, whatever normal is, then you probably have an a of 1, right? Do you remember the stretching that those coefficients do? And that's what your a does. So it's kind of easy to see in some of them if you're going to have an a other than 1. So you need to be really careful when you're solving it. Okay? And again, wide means a fraction or decimal, narrow means a whole number. Also, a can have a sign. That's easy. Parabola opening up, that means your a is positive. Parabola opening down means your a is negative. So if you make a sign error there, you can kind of check it by looking at your. Okay? So, first, you're going to put the x values into the form, and there's your form, making sure that you change those signs. Second, choose any other point on the line, on your parabola, right? The parabola is a line, yeah? So any other point on that line. Ideally, it'll be the y-intercept, because that gives you an x value of 0, which is nice, right? But doesn't matter. Any other point. Then you're going to substitute that value in place of y and the 2 x's, usually, unless one of them's fallen out for some weird reason that you've done some up there, the 2 x's, and solve to get a. Now, you know me, I write things out in great detail. This is a lot faster and easier to do than it is to explain. When you see it, you're going to go, okay. Because we've done substitution before. That just means plug the number in and do the math, right? And you're just going to solve the equation. It's always going to be a linear equation because you're going to have numbers in place of your x's, so you're never going to have an x times an x. So it'll all these be linear. It's really easy to solve. Okay? All right. So let's take a look at one. Oh, sure. No worries. Sorry. So we're just going to go to the book and take a look at one of these. They have the samples there, but I'm going to just go to one like the way you look. First of all, they're going to give you this one where you have a chart. They give you 2 extra points. You don't really need 2 extra points. Any point on the line will work. So this is on page 43 if you're following along in your book. Draw graphs for the following equations. We already did this graphs. Never mind. I'm on the wrong page because we were reviewing. So don't look at that. Writing the equations. So let's try page 40. There we go. Page 46. Here we go. First, mark all the integral points. Now, integral points for this because if you look at this graph, at this particular graph, can I find the x-intercepts easily? Yes. Do you know what the vertex is? It's ugly in this one. It's fractions everywhere. Okay? So this one, definitely we want to use the x-intercepts. Right? So first thing I need to do is find those x-intercepts and put them in that form, y equals a times x plus or minus times plus x plus or minus. So the first x-intercept over here is -1, and this one is +4. So when I put them in here, it's going to be a plus 1 and a minus 4 in no particular order. The order of those makes no difference at all. Okay? Yes? Because remember, if you take it away from an x, it changes the sign. When you put it back with an x, it also changes the sign. So anytime you put a value in with an x value in the bracket, it always changes its sign. Good question. Okay? All right? Now, we're going to substitute the coordinates of another integral point. And they say integral point, that just means any point you can see. And in this particular one, I like that point right there. Can anybody tell me why I like that point right there? Yeah, it's the y-intercept, so the x value is going to be 0. So my point is 0, -4. Now, it doesn't mean I'm working with a negative number, but, who cares? Remember which one's x and which one's y. Yeah? Now, we're going to solve this equation using that point. So our equation we have right now is y equals a times x plus 1. I'm just rewriting what we have up there just so that you can see it easily. Okay? So in place of every y, I'm going to put what value? -4. There you go. I don't have an a, so it's just going to stay a. In place of every x, I'm going to put what value? 0. And what is that going to do to your x's when you put a 0 in there? Makes it go away. So 0 plus 1 is going to make 1. 0 minus 4 is going to make -4. Can I skip that step and you're okay with that? So all I did was plug in 0 in place of the x's. And that's why we like to use 0 if we can. Now, if the intercept had been at some point where you can't read it easily, then you can't use it. Use some other point. Don't use the intercepts for the x-intercepts, though, because it won't help you. Okay? So don't pick these same points because you've already done the values with those. Pick some other point somewhere, anywhere else. Okay? Now, do the math. -4. So this is going to get us -4 equals 1 times -4 is -4, and -4 times a is -4a. See, I just multiplied those two brackets together and then multiplied that times my a. And traditionally the numbers come first. That's why it's -4a instead of a times -4. Okay? Now, simple linear equation. How do I solve it? Just divide both sides by -4. Or, I could have changed those signs and divided by +4 if I wanted to, right? If you don't like working negatives. So that gives you a equals what? 1. Okay? Well, that means my a is 1. So if I plug in a 1 in place of that a, do I even need to put in a 1 there? Nope. So we'll just pretend it's not there. So my equation is simply x plus 1 times x minus 4. And I kind of knew that it was going to be a 1 based on the width of the parabola. You're going to get used to seeing them and seeing, that one looks about right. Okay? Okay. There's your equation. Pretty straightforward, right? Now your problem is you have to memorize when to use it and what to do. So don't be just cranking through these problems without thinking about what it is you're doing. That's why they give you these problems where you have the pieces that you're filling in so that you can train your brain to look for those pieces, right? So study the notes so you'll know what you're working on. If you do no homework at all, but you memorized those notes and watched me do examples, you would do better on the test than someone who did all their homework but never studied their notes. I have years of data to prove it. Because I had university students who would take notes but never do any homework, but they would study their notes. They could quote them back to me. Perfect scores. It's that important, right? Think about it. The directions is what you need, right? Where am I going and how do I get there? Not, that should be a 5. Does it make sense? So you can always find these numbers if you know the process. You can never find them if you don't know the process. Or you might find some of it you might memorize. But if you memorize the notes, and memorizing means quote them back. If you can't teach it to someone else, you don't know it. All right? You need that level of security. But it's easy because we break it down into small pieces and you just need to memorize those steps. Now, do you have to memorize it exactly the way I wrote it? No, because it might make sense to you just to write something, some small thing with some abbreviations, right? I'm not saying you have to memorize what I say or write. I'm just saying memorize it in a format that you can understand it. Yes?
What week next is this?
I think this test is in the school exams.
Is it?
So week 3? Week 3 or 4?
Is it before the MCAT?
Yes, before the MCAT.
When's the MCAT?
Week 5 or 6 or something like that. Yeah, we'll look at the calendar afterwards. Okay, let's move on. Look at another one of these. This one looks interesting. Why? It's wide. Well, it's wide, isn't it? Okay. This one looks interesting. Why? Going down. Let's see if we can find one that goes down and is wider. That might do it. Does that look wide to you? Maybe? Maybe. We'll see. Okay? And we've got no training wheels. So we got to do everything ourselves. So first thing I need to ask myself, I'm looking for the equation of a parabola. There are how many methods? 2. The first one is when you can easily find the, what are they called? X-intercepts. Can I easily find the x-intercepts here? Yes. Okay? If that's the case, then I'm going to use y equals a times x plus or minus p times x plus or minus q. Or your favorite letter, insert there. I don't care. Okay? As long as you use a. I like a because you'll see that it has lots of repetition. Okay? But p and q, who cares? Now, your x-intercepts are -5 and what? 0. Isn't it? Okay? So -5 and 0. Oh, -7? Oh, I can't read. Oh, well. Just wait. One of these days you're going to be old and blind too. Okay. -7 and 0. Thank you. Okay. Now we have those two x-intercepts. Now I'm just going to plug those into the right place in the equation. So I'm going to get y equals a times x, what? -7? Plus 7. Good. And x plus 0, which we'll clean up in a second. Okay? Now, that gives me y equals a times x plus 7. Where did I get this just plain old x?
X plus 0 is just x.
Just x. There you go. So you want to clean it up because you don't want to have all that stuff hanging out if you can avoid it.
So the x isn't in a bracket and you just put it there?
Yeah, you don't need a bracket because it's all one term. It's just an x, right? So anytime you get that case, just get rid of it. All right. Now, but do remember, we're still going to have to substitute in a minute. So if you want to leave the bracket around it, it's perfectly fine. At the very end, you won't. But if you want to leave it now, because we're going to do substitution in which you're going to have to put the bracket in anyway. So I'm going to choose any integral point. I can't use the y-intercept this time. Why? Yeah, it's the same as the x-intercept, right? So I'm going to have to choose some other point, some other value. And it doesn't matter what point you choose. Just make sure that you're really looking at a point on the graph that you can read the values from, not think you can, right? So do you see a point that you could read easily?
1, -4.
1, -4? Looks good to me. Okay? Doesn't matter. So we're going to use, so our integral point, we're going to use 1, -4. So that just means everywhere there's an x, I'm going to put a 1. Everywhere there's a y, I'm going to put -4. And that'll allow me to solve for my a. So -4 equals a times 1 plus 7. You write as much or as little as you need in order to make sure that you get the right answer. But remember, when you put the x value in there, there's always going to be two x's, two places to put the x value, and 1 for the y. Which gives me -4 equals, well, a times 1 is just a, so who cares about that 1? 1 plus 7 is 8, and 8 times a is 8a. It's all good? Okay. Then we're going to divide both sides by 8, and be careful. When we divide -4 by 8, we're going to get a negative. We knew that because it's opening down. And 4 divided by 8 is not 2. 4 divided by 8 is what?
1/2.
There you go. And we figured it was going to be a fraction. Why?
Because it's wide.
It looked wide. There you go. So a is -1/2. So let's finish out and write our final equation. Y equals -1/2 is our a. We have that one plain little x all by itself. We don't need the bracket anymore, but it wouldn't be wrong if you left it. And the other bracket was x plus 7. And this is your completed equation. Looks good? And again, none of the math is hard, but you have to remember when to do what and where to get the values that you need. Okay? All right.
So how would you then use that equation to like do something with the graph? Like if you have
Well, you wouldn't. It's already graphed, so it's done,
Yeah.
right? So you wouldn't. It's just you're using the graph. You would either use an equation to make a graph or use a graph to make an equation. Where this is really going to make sense to you, that you can equate one to the other and find them, is when we do the applications. Because they may tell you the x-intercepts are, find the equation. Well, you know something about the graph, and you can do that. Now, you couldn't find it with just the x-intercepts, but you see what I'm saying? So they're going to give you pieces, and you have to figure it out. Sometimes you can draw a picture, and from the picture get the equation. Sometimes you can write an equation, and from the equation draw the graph. Yeah.
Would you be wrong if you write -1/2 x plus 7 and then x?
No. Traditionally, if you have a plain old x, it always comes first.
Okay.
Yeah.
But I was even wrong if I like
You wouldn't be wrong if you had the x hanging out at the back. It just looks funny. Yeah. Okay. All right. Now. All right. So for today, we'll just look at this first method. So let's look at the homework. Again, I've done a couple of them for you.
46 and
But
47.
I would still do those anyway. Yeah. So pages 46 and it stops on page 47. Okay. Yep. Okay. So pages 46 and 47. Just work on all of those. We've done a couple of them, but try to make it might be better if your brain was pushing the pencil and you tried them again. So pages 46 and 47. Just work on all of those. All right. There we go.